Last question on paper 1 is about heat transfer. You have been given a description of an experiment where there's 4 containers that are rigged up in different ways to change the heat transfer. Student places boiling water into each of the 4, then she records how the temperature of the water in each container varies with time. So the first question says, how could the student make sure that the investigation is a fair test? So as soon as you see fair test, you should think controlled variables. So which variables is the student controlling here? For each of these containers, she is keeping the temperature of the initial temperature of the water constant, because she's putting boiling water, which is going to be at 100 degrees C, hopefully, into each of the containers. Another one that she should keep the same, it's might be harder to think of because it's not given in the question, is that she should keep the volume for water the same. Now when you look at the 4 containers, obviously C is bigger, C has a bigger volume than the other 3, but to keep the test fair, she should put the same volume, the same amount of boiling water into each of the 4 containers. And the third thing that she should keep the same is the time. So if she's investigating how the temperature changes over a certain amount of time, then she should keep that time the same. Part BI. Explain which container loses the most thermal energy by radiation. So anything to do with radiation, you should be thinking about the colour of the surfaces. We have got 3 shiny metal containers and 1 metal container that's painted black. So this is just a knowledge question. The black surface is going to be the best emitter of radiation. So the container that loses the most thermal energy by radiation is B. For part 2, explain which container loses the most thermal energy by convection. A little bit trickier. Convection is affected by how big the surface area is, essentially. So convection is going to be happening from each of these containers at the top. Now for part D, because it's got a lid on it, that's going to cut down on convection. It's going to cut down on convection because the air above the lid is not going to be heated as much as it is for the other 3. But this is also, container C has got the biggest area in contact with the air. So this is going to be transferring the most amount of heat energy through convection because it's got the most contact with the air above it. So that's for this question. After 20 minutes, container D has the highest temperature. Explain why it remains hot for the longest time. So you've got possible 4 marks here, and you need to talk about all the different features. Don't just talk about the features, talk about what heat transfer method it is cutting down on. So I've already said one of them. The lid on top is going to cut down on, you can either say conduction into the air above it or convection of the air above it. Either of those is right. You can talk about the fact that it's surrounded by cotton wool. So cotton wool does 2 things. It's a good insulator, so it's a bad conductor. And the reason it works so well as an insulator is because it has air trapped inside it. And trapped air works very well for 2 reasons. First of all, it's air, so it's a bad conductor because the particles within the air are so far apart they don't conduct heat energy by collisions very well. And because the air is trapped, it can't move around, so it can't do convection either. So trapped air is a really key idea when you're getting any question to do with heat transfer. So the fact that it's air cuts down on conduction, and the fact that it's trapped cuts down on convection. Then you've got, I don't think it's as easy to see, but you can just about see that the metal container underneath is still a shiny metal container. And because it is a shiny surface, that means it is a poor or a bad emitter of radiation. So that will get you an extra mark as well.